present. Okay. Here we go. 25-step process to get everyone to see the same thing here. That's for you. That's for you. I'm gonna go away. Can I pin that bad boy? There we go. Okay. I was annoyed yesterday with graphing on the board, so we'll just do it this way today. So welcome everyone. So once again, the timing's kind of weird with this, but life is just weird from now on. So some people, once again, we're kind of splitting up this exam and you're taking it in class. So cohort B, you're taking it Friday in class, and cohort A, you're taking it Monday in class, but we're reviewing today. So it's just kind of, once again, kind of weird timing. But if nothing else, then you have the review and you will look it over and you will do this crazy little thing called study. Yes, ma'am. Yes. So, ooh, we're getting nuts here. So our main goal today is we have this nice little review scheme, pretty similar to what the assessment will look like. I'm not going to put a ton of graphing on there, though maybe there might be like one graphing, so I won't overdo the graphing. I know those are just kind of annoying. But then we will see substitution, elimination, and a few word problems. So what we're going to focus on, maybe we'll choose like 2 from each section to start, and then you guys will have a little bit of time to go back and try a few. See if you have questions before you leave today. And then we'll kind of, I'll still see you tomorrow, so you still have plenty of time to ask questions. It's more just kind of while we're together now. So I'm going to grab a ruler for myself. Beep. This little pink boy. So let's look at some graph-arooning. Actually, we can do all these. These are quick. So number 1, I feel like I kind of picked 3 different cases just to remind ourselves of some stuff going on. Number 1, we have nice slope-intercept form. Always my favorite. The y-intercept is 1 for the first one, right? Y equals mx plus b. B is our y-intercept. Our slope is 4 over 1. So we're going to rise 4, run 1. What I suggest you do is I like to extend and have a few points. 1, 2, 3, 4, 1. I can also go down 1, 2, 3, 4 to the left. You might actually already even see what the answer is. But we have our nice line, and I'm going to connect it. Good stuff, good stuff. Boop, 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 boop. Lines are infinite. I'll put my little arrows. Okay, so then I go back and basically do the other equation on the same graph. The y-intercept is 1. That's why that one's kind of easy, because they have the same y-intercept. So we kind of can see where they're going to meet. So I can do a few points if I'd like, but I already see their meeting point, and that is at the y-intercept. If I do ask you to solve by graphing, 1, you have to graph it. So please don't be like, oh, well, I'll just solve a substitution and give her the answer. No, I want to see the graph. And 2, you have to label your point where they meet, and that would be the point 0, 1. Okay, so I want to see that actual answer. So just as a heads up for that one. Number 2 is just like, I always get to those ones. I'm like, ugh, like, we really have to? Yeah, you do. So unfortunately, that's life. And we're going to have to do a little rearranging. Okay, I can do that. So for the first one, I'm going to subtract 5x. Once again, I'm a big y equals mx plus b fan for graphing. It's usually not that bad to rearrange to it. And then once it's rearranged, it's pretty quick. So I move the 5x, and I'm going to divide everything by 6. And I get y equals negative 5 over 6x plus 2. So I divide those. Okay, so that wasn't that bad. So I'm just going to graph it while I got it. Oh, excuse me, I'm losing my voice here. Excuse me. I'm going to go down. Oh my God, I'm really struggling today. Down 5. 1, 2, 3, 4, 5. To the right 6. 1, 2, 3, 4, 5, 6. These little graphs like kill your eyes. I'm not going to be able to extend it anymore this way, but I'm going to try to go up 5 to the left 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh my God, when you like concentrate on those little lines, it like hurts me. All right, so we got a nice little line here. Excuse me. Boy, voice is struggling. I'm talking too much today. And basically, we have to do the same thing with the other equation. So I'm going to move that 3x. I've kind of run out of room here. I guess I'll just do my work up here. I get negative 2y equals negative 3x minus 4. And I'm going to divide everything by negative 2. And I'll get y equals 3 over 2x plus 2. Okay. Oh, come on. Then y-intercepts are the same again. How easy could that be? The y-intercept's 2. I can rise 3, run 2. But I really don't need to do much more because I can already see where they meet. They're not always going to meet at the y-intercept. Those two were just magical. Excuse me. Struggling. Please label your points. In this case, the point would be 0, 2. And then just quickly, I wanted to do 3. And we talked about it quick yesterday. Hey, everyone. If I say x equals a number, is that horizontal or vertical? It's vertical. Okay, think about the opposite of the actual x-axis is vertical. So when I say x equals 5, you go over to x equals 5. 1, 2, 3, 4, 5. And then you draw a vertical line. Or just think about points where the x is 5. And it would make a nice vertical line right there. For y equals negative 3, if it's y equals, it's a horizontal when there's no x in there. So we go down to negative 3. And it's a horizontal line. And then it kind of makes sense when you think about where they meet. They meet at the point 5, negative 3, because the x is 5 and the y is negative 3. But just as a reminder, those vertical and horizontal lines do pop up. So I just wanted to remind you of them. Okay, good stuff, guys. Are there any questions right now on graphing? Hold on, I'm just checking quick.
Sorry, I probably should have asked this earlier, but I wasn't able to print it out. It's okay if I just kind of sketch these in my...
Absolutely, yep. Just doing sketches is fine. Okay. Yeah, not a problem. I know not everyone has a printer, and printers are annoying, and I feel like every time I need to print something important, I run out of ink. So, yep, feel free to just sketch them on your notebook. That's fine. That's my fault. I wasn't a good planner. I should always print stuff early for you, but vacation kind of threw me off there. All right, so any questions on graphing? There will only be one graph, so I'm not going to make anything too crazy. I'm not going to give you a million graphs. Graphing is more just to remind you of the concept. The concept is we have 2 lines. We're seeing where they meet. So where they meet is your answer, is your solution. And then just as a reminder of the special cases, if you have 2 lines that are parallel, it would be no solution. And if you have 2 lines that are the same line, so they're the same exact thing, that would be infinitely many solution. So just as a reminder. Okay, so then we have a good old substitution section. We're not going to do all of these together, but we'll pick 2. So let's start with number 4. We'll do the first one, and then I'm going to kind of skip around and see a second one. So a reminder of substitution. Substitute means to replace. So when we're doing substitution, we always start with the equation where the variable is isolated. So it's either x equals or y equals. So I'm going to start here. I'm a circler, so I'm going to circle it. I'm saying that x is equal to this. If 2 things are equal, they represent the same thing. We're just representing in different ways. But just as a reminder, go to the equation where the variable is by itself. Once you've done that, you are going to take x and we're going to replace it with this in the other equation. So what I always do is I kind of draw the arrow up just to remind myself. Where I see x, I'm now going to replace it with this and then just kind of fill in my equation around it. So x is negative 4y plus 5. The reason I don't put in parentheses is because there's no coefficient to x. If there was like a 2 in front of x, you would have to put that in parentheses. But since it's just x, yeah, you can throw a 1 there if you want. Or you can just kind of just plug it in. You're good. So x is being replaced with that. And then the rest of the equation, we have plus 5y equals 2. So just take a second and kind of visualize. I basically rewrote this top equation. The only difference is now that x is getting replaced with negative 4y plus 5. And then I just kind of fill in the equation around that. So the reason we do that is now we have one variable, we can actually solve it, and then once we solve it, we can use it to find our x. So combine like terms, negative 4y plus 5y is just y. So that's a quick solve to get y by itself. Y is going to equal negative 3. Okay. Just as a reminder, so this is what I always do when I'm doing systems, because I tend to get like distracted. You're like, yeah, I'm good. I solved it. I always remind myself, I always kind of put my point right there. And I remind myself, I only have half of an answer. So please make sure you're finding X and Y for every single problem. So now that I have Y, I can just plug it in. You can pick either equation. I'm going to pick the second one because I'm solving for X and it's X equals. So I pick the equation. I'm going to plug y in that I just found, and I'm going to find x. So that would give me what? 12 plus 5, and that would be 17 for x. And now I have my final answer for my point. 17 comma negative 3. What a beauty. So 5 is nice. Same idea. Take x, plug it in. 7 is nice. Same idea. Just pay attention to what variable you have. In that case, you have y, so plug it in. 6 and 8 aren't necessarily set up for substitution because a variable is not isolated. So if you need to, just isolate a variable. So I'm going to do 8. Doesn't really matter which one you do, but I don't know. I'm feeling like 8's where I want to go. Look at the equation if it says substitution, read directions, and say like, oh, crud, like it's not the setup that I need. So I just need to get one of these variables by itself to start. Pick one. So always pick the one that there's no number in front of. So either this one we can rearrange for X or this one we can rearrange for Y. It doesn't matter. So I'm going to rearrange this first one for X. So when I see rearrange, just get X by itself. We've done that a million times this year. X is going to equal negative 5y plus 8. So in order to kind of do the setup, you might have to move things around. Now I'm going to take this, and where I see X down here, I'm going to replace it. So we have 2. X gets replaced with negative 5y plus 8. And then we have, after that, we have plus y equals 16. I'll give you a second just to kind of visualize what happened. We had 2 equations. We had to pick one because we needed substitution. So you need one of them where the variable was by itself. So I just kind of moved something around to get X by itself. And since I have X equals, I put it in where I see X in the other equation. I replace it. So basically this looks like this equation with just X replaced with what it's equal to. And now we just have a little solving to do. What do we got? Negative 10y plus 16 plus y equals 16. All right, let's combine these like terms. That gives me negative 9y plus 16 equals 16. And let's do a little solving. A few steps here. Ooh, equals 0. Zeros freak people out. Don't let it freak you out. Y is equal to 0. Please do not write no solution, something weird. 0, that's fine. You can have 0 as an answer. I don't know why people are so offended by that. So what I'm going to do is I'm going to set up, okay, I'm finding a point. I have the y. Okay. Remember, you can only have a special case if all the variables cancel. Okay, let's take that y and plug it back in. Plug it in wherever you please. I'm going to plug it into this rearranged one. Why not? Because I'm looking for x. And when I plug it in, I just get 0 plus 8. So x is just 8. So having 0 as a part of a point is perfectly fine. Up here, we had zeros as points, and it was fine. It didn't freak people out. But just be aware, having a 0 as part of your point is fine. It just means it's on an axis. Isn't that just beautiful? Sorry, I just have to look at my problems on the back. Okay, so as of right now, we picked 2, but does anyone have any questions with substitution? concept, idea, anything, life. Okay. Let's do 2 elimination, then we'll just look at a word problem, and then you guys will try a few. I will be checking in the end. I'm going to give you some to try. So we might not do every problem today, and that's okay. And then once again, the people at home, you will be scanning this in. So if it's not the perfect worksheet, that's fine. Hi, Mr. Ringette. How are you today? That's just fabulous as always. We're just doing some systems, you know. Love of life as always.
I love systems and equations.
Oh, me too.
They
Aren't
can
they
solve so many different things.
I know. It is just like, hey, do you use it in your real life all the time, Mr. Ringette? I do
All
all the
right,
time. I'm talking to Mr. Ringette.
not as much as I used to.
Okay, so you did
I will
actually
say
use it at
that.
one time. Okay.
Not as much as I used to.
Well, yeah.
But when I have to intersect certain things
Well, yeah, exactly.
mathematically, like so I'm planning on building. I have to rebuild my deck. This
Oh, have fun with that.
And there's a lot of little math intricacies that I.
Oh my God, I know. Building is like crazy.
So, yeah.
Nice.
So I gotta do a little bit of that.
A little bit of this, a little bit of that.
Yeah. Sometimes you have to figure out where a plane intersects a line. Stuff like that.
Yeah. We're not that crazy yet, but nice. All right, substitution, we're good. Everyone at home's good. Okay. So let's do elimination. We'll look at the most basic one and then we'll kind of work our way up. So elimination, once again, you want everything lined up. So if everything's not lined up in standard form, rearrange it. So this is the most basic one because when I add these 2 equations, just to start, we see something eliminates right away anyways. So that's nice. And just a reminder to eliminate, which we'll have to do in a few minutes, the coefficients are the same and the signs are opposite. So you want the same number, opposite signs. So if that doesn't happen, we'll have to do it. But we basically just add everything. Okay, that's not bad. 7x equals, what's 31 minus 45? Negative 14. I was like, elimination, I feel like the first step is like, oh, that's like super quick. 1 step, we're good. X equals negative 2. So what I do right at this point, I said, I make a point and I put my X to remind myself I still need Y. So that's, I'm going to say this is my 15th year teaching. Every year someone just like forgets. It's like, oh, wait, you need a point? Like, yeah, we've done is point. So don't forget. Like you feel like you're good because you solved something, you still need that other part. So this, I feel like the second part's always kind of the pain part. You pick an equation. I'm going to pick the first one. You plug in what you know. Sorry, I'm writing like awkwardly sideways right now. I don't know what's going on with the way I'm writing here. Let me move that bad boy. I know that X is negative 2, so I'm going to throw that X in. And I'm going to do some simplifying and solving. So when I say simplify, 2 times negative 2 is negative 4. And then we just have a few steps to get to that Y. 7y equals 35, so y equals 5. Beautiful. I have a final answer. I'm going to be honest. I still to this day, well, I'm a rusher, so I like rush through problems. You know, I'm doing an answer key. I still to this day check my answers. So what I do is I grab a calculator, even when I'm doing my answer keys. Like, obviously I know how to do this, but we make silly mistakes sometimes. So especially if I have like extra time, or if I come out to a weird answer and I'm like a little iffy on it, I just grab my calculator and I say, I plug in both my points and see if they work. So ready? 2 times x plus 7 times y. So I plug in x and y. And when I hit enter, it should be 31. And it is. So that makes me feel better. Okay, I'm good. And I do check it in both equations. So 5 times x minus 7 times y. And when I hit enter, it should be negative 45. So that's a good way to check yourself, especially if you have extra time on an assessment. You can basically leave like, no, I'm like, I did pretty good because I checked my answers. And you don't have to actually do extra work. You just throw it in your calculator. But I still to this day do that, especially when I second guess myself about an answer. I'm like, I don't know if that's right. I just throw the x and y back in to check that one side does equal the other. But that's a good thing to get into the habit of doing. I'm just going to skip around. I feel like I'm just running out of room. I just need I need freshness here. Okay, so I'm going to the back. If you're at home, you can just kind of label. So let's look at 12. I'm just picking a random one. And then we'll look at a word problem. So number 12, I'm saying, okay, I need a good old elimination. And I like elimination when things are lined up like that. It's like the nice setup. And I just say to myself, well, is anything going to eliminate right now? No, because the numbers in front would have to be the same. So that's out. And I would say, which is going to be easier? And I guess there really is no easier one because we need to either make 4 match 5. That's not going to happen just by multiplying 1, or 3 to 4 is not going to happen. So we're going to have to multiply both equations. Okay. So pick which one you want to choose. I'm going to cancel my y's. So this, you might have totally different work if you cancel x's, and that's fine. Our answer should be the same. So in my head, I say, ooh, a 3 and a 4. I need to make those match. So I'm going to make them a 12. So I'm going to multiply this by 4 and this by 3. And if you're ever stuck and you don't know, you can just multiply them by each other, right? If I have 4 and 3, you multiply by 4 and 3. So now I'm going to just give myself some room over here. That gives me 16x minus 12y equals something. I'm grabbing my calculator because I'm lazy. Equals 68. Okay. Have a calculator because it makes life way easier. You don't want to be sitting there doing like that computation for 3 minutes when you could have just thrown it in. And then that gives me what? 15x. My signs were already opposite, so that's why I didn't have to change any signs. Plus 12y equals 3 times. Oh, I could have done 3 times 60 in my head, Mrs. Sherman. Okay, there we go. Let's add those babies. 16 plus 15 is 31. Negative 12 plus 12 eliminates, which is always my main goal. And what's 68 plus 180? I have no clue, and I'm too lazy to figure it out. And it's 248. Okay. I'm still like, let's divide by 31. Oh, delightful. The answer is 8. Okay. That makes me, once you get like a nice number, I always feel better about myself. Okay. So we got 8. So I remind myself, I'm going to make a point. I have the 8. I need to find the y. I have the x. I need to find the y, I should say. Let's plug it in. Let's plug it in. Pick an equation. Doesn't matter which one. I usually go back to the originals, and I usually pick the one with the smallest numbers just out of habit. So I'm going to pick that first equation, that first original equation. I'm going to plug in my x. I'm going to do a little simplifying. So 4 times 8 is 32. And then minus 3y equals 17. Now I have a 2-step equation. I always feel like the second part of this is like a little bit more work here. Don't lose signs. So like make sure that negative comes down with a 3. So those are the little mistakes I see people make. And then we divide. And a negative divided by a negative is a positive. And now we have a final answer. What a beauty. Oh, what's up? Yeah. So it doesn't matter where you start, whether you're on 13 or one on the ones in the front. Just make sure your first goal, 1, that everything's lined up. 2, that you can eliminate a variable. And you do that by making the numbers in front, the coefficients the same with opposite signs. That's always kind of your first step. Does anyone think they have any questions on elimination? Okay. And we're just going to do one word problem. They're all pretty similar. So I'm not going to, I have some crazy ones. I'm going to spare you those because they take like 3 days to do and we just don't have the time, unfortunately. Well, not to do one problem. You have to do multiple. Yeah. Yeah. They take a while. They're pretty hard. So I'm sparing you. We can always go back if we have extra time.
I think we're good.
Yeah. I want to get to the end stuff. That's the good stuff. We're still in like the okay stuff. This is like all right. Once we get to chapter 8, that's the good stuff.
What's in chapter 8?
Polynomials, factoring. That's the real good. So then we do quadratics.
So like shapes?
No, quadratics is one. It's just one specific shape. So, yeah, it's fun. It's fun, guys. It'll be a blast.
So fun.
Okay, so all of them are pretty similar in the fact that you're just kind of, you're reading through. So in 14, we're selling some cookies. We got sugar cookies and gingerbread cookies. There you go. Cody sold 8 packages of sugar and 9 of gingerbread for $103. Juan sold 4 of sugar and 3 of gingerbread for $41. Find the cost of each. Your main goal when you're starting, and I'm going to be specific with this in the directions. The first thing before it even says set up a system, because you do need to do that as well, it will say define your variables. So what does each thing mean? You can use S and G for sugar and gingerbread. I hate S's. They look like 5s. So I'm going to use X and Y. I'm going to say X is the cost of sugar cookie. Sorry, I know I'm off to the side there. And I'm going to say Y is the cost of gingerbread. Bread, a cookie. So what are we looking for? That's your variables. And then these should be pretty, they shouldn't be too bad. So for each person, they get their own equation. So we have 8 packages of sugar and 9 of gingerbread for a total of $103. And then we have 4 packages of sugar and 3 of gingerbread for $41. So let me know if you're having any issue actually setting those up. Any probs? No? All right, let's solve this one just for fun, That's the way we do it. You can pick because either variable would basically be the same amount of work. I'm going to cancel the x's. It's just what I saw first. So if this is 8, I can make that into an 8 pretty easily. So I only need to multiply one equation. And to make a 4 into an 8, I'll multiply by 2. And since this is positive, I want to make that negative because, right, I want them to be opposite signs. Same number, opposite signs. I like to rewrite everything. I know some people like to kind of just like do their thing. Just be careful and stay organized. That will give me negative 8x minus 6y equals negative 82. And now I can add. We got a little elimination going on. We got 3y equals 103 minus 8. Oops. Is that? I didn't say that. It must be 21. So y equals 7. So what does that mean, you say? Well, I remind myself what y is. It's the cost of gingerbread cookies. So it's $7 for a package of gingerbread cookies. God, writing the word gingerbread is annoying. I should say for a package of. Okay, so that's my first variable. You don't necessarily need to write these as a point. We just need to find both of them. So let's find out what the sugar costs. Go back to an original. I'm going to go to that second one, the 4x plus 3y equals 41. You can go to either because, once again, no matter where you plug it in, we should get the same answer. We know that y is 7. So we're going to do a little bit of solving. Mr. Sherman's running out of room here. You get the idea. 4x equals 20, so x equals 5. So $5 for a package of sugar cookies. So once again, if it's a word problem, you don't really need to write it as a point. We're kind of talking more about context there. But if you do write it as a point, that's fine. Yep, absolutely. Go ahead. So my friends, that is the main idea. There will also be one extra credit that is similar to what we were doing yesterday. So it is the graphs that you're shading. And then putting the either solid line or dotted line. So you might want to look that over because it's always nice to get an extra credit, correct? But other than that, there'll be a few substitution, a few elimination, maybe one graphing, a few word problems. I don't know, maybe a few other things kind of thrown in, but that have to do with that stuff. And then there will be an extra credit once again on the stuff we were doing yesterday with graphing linear inequalities. All right, so here's the deal. Right now, everyone is trying, so I'm just going to give you one from each section. So can you do number 7? Can you do number 11? And can you do number 16? So I'm going to write that right at the bottom right now. Number 7, 11, and 16. I'll leave that up for a minute. So you guys are trying those. For the people here, I'm going to check yours because I'm checking the people's at home. So I'm going to keep it nice. And then for the people at home, you will be submitting these in a few minutes. So just as a heads up there. So I need to see the ones that we've done plus the 7, 11, and 16 for credit. So I'll give everyone a few minutes to work. In a minute, I'm going to take down my screen just because I want to do attendance. So write down 7, 11, 16 so you got them, but I'll leave it up for another second. And please, in the meantime, if you have questions, ask them. So don't sit there and be like, I don't know what I'm doing, but she'll do it later. Well, yeah, because I know how to do it. You need to know how to do it. So please make sure you're getting on that. If you need help, please ask. Take attendance for the people here.
Mrs. Sherman,
What's up?
what's the difference between infinite many and no solution again?
So when you're solving, so your variables would cancel. And let's say your variables cancel and you got something like 2 equals 7. That doesn't make sense, right? So that would be no solution.
Oh, all right.
But if you got something like 7 equals 7, and that is a true statement, that would be infinitely many solutions. So it comes down to what?
Can we just put infinite? Or?
Yeah, that's fine. So it just comes down to whether the statement that's left is true or not. So if it's true, it's infinitely many. If it's not true, it's no solution.
All right, thank you.
You're welcome. Page 8 and Haley, delightful. Oh my goodness. I hate teaching at my desk, but sometimes it's just easier with graphs. I'm going to turn the light on, guys, so just brace your eyeballs. All right, so I'm going to stop sharing my screen with you guys.